Hi, welcome back to the Introduction to Python Programming. This is section 6, loops. And loops are another important concept across probably most programming languages, if not all. Lesson objectives for this lesson include understanding the following: while and for loops, break, continue, loops and loops, and of course we have the commit there at the bottom, which is how we access the resources for this lesson from our version control. While and for loops. While loops. Loop until some condition is false. So on line 5, we have while b is less than or equal to 10. We have an indented command which goes under that loop, which is part of that loop once it's indented underneath it. There's only one line of code right now, but we could have easily had 10, 20, 100 lines of code indented under that while loop, and that would all be code that would execute with that while loop. But right now it's just one line, which is the b equal to b plus 1. So if we look at lines, if we look at lines 1 and 2, we can see a is equal to 10, b is equal to 0. And then while b is less than or equal to 10, b equals b plus 1. So the variable b is incrementing, and then once it gets over the value of 10, the while loop will finish because that condition will be false. So how many data objects were created? Well, we know that the integer is an immutable object. So every time b gets a new value set, a new data object is created. So we're creating either 10 or 11 data objects right there. Recall that the integer is immutable. What prints out? Well, when we print b, b has to be less than or equal to 10 for it to exit the while loop. So that means when b is 11, it will exit, and then we will print out the value 11. Okay. Next, we move on to the for loop. Loop through a set of items in a list, also known as iteration. So on line 11, we have C equal to a list of letters A through F. On line 12, we have C3 within a brackets equal to Z. So we're changing the value of A, B, C, D. We're changing the value of D to Z. And the reason it's D and not C is because we start counting at 0. So A is 0, B is 1, C is 2, D is 3. Now, does that create how many data objects are created in line 11 and 12? Well, if you think 2 data objects are created, I'm sorry, that's incorrect. Remember, the list is a mutable type, which means we can change the values of a list without Python creating a new data object. So when we run line 12, a new data object is not created. The value of C3 is actually updated to the value Z. And then in lines 14, we have that iteration example. We say for item in C, item becomes the value of the current list item that is being looped through. So the value of item on the first iteration will be A, on the second iteration will be B, on the third iteration will be C, until it gets to F and then finishes with F. So the last iteration will be F. And again, right now in this example in line 15, we have one indented line of code, but we could have easily had 20 indented line of codes in that loop statement, and all those lines of code would be related to that loop execution. Now let's go ahead and move on to the next item. Break and continue. Break. Leave a loop prematurely. Typically used if some condition is true. So at line 6, we can say if b is equal to 10, break. So what's going to happen here is that once b is equal to 10, it's going to break, and then if we print b, it's going to of course print 10 instead of 11 because it doesn't finish the iteration. It breaks out of the loop. So break again lets you leave a loop anytime you want given some condition. Now you wouldn't have to put a condition for a break to be used. You could just use it by itself, but that wouldn't make any sense really. Typically you're going to have a condition that when it's true you want to leave the loop. Continue. Immediately proceed to the next iteration. For example, maybe you want to skip an item in a list given some condition. For example, on line 18, we have the continue statement, and that's under the if statement if item is equal to Z. So when we get to the item Z in the iteration, we're not going to print that item. We're going to skip over it. So again, in that list, D is changed to a Z. Then we iterate through that list, and as we iterate through that list, each loop iteration becomes the item that the current list item that the loop is on. So it'll be A, B, C, Z, and when it's equal to Z, it's going to hit that continue statement because the equality is going to test true, and it won't print out the Z. So continue lets you essentially possibly skip an item in list iteration. So break in a while. So on that last bullet point says you could typically make a break condition part of the loop condition. So we could say if b is less than or equal to 10 and b is equal to 10, and then we could lengthen that out a bit. But for readability's sake, you may want conditional breaks in a large loop. So you might not want a while with a bunch of ands and ors in the condition, but instead use conditions throughout the loop that break out when you need them. And that would be so that it's more readable, even though both ways could be set up to work. In fact, that's a major goal of a lot of software engineering teams when they're working on code, is to make sure that it's readable so that most people can just read it and understand what's happening. It's an important thing to try and follow. So let's go ahead and move on. Loops in loops. So on this slide, we start to talk about efficiency a little bit. So efficiency, the more loops within other loops, the worse the performance is going to be. Now, this becomes a major factor when you have very long lists, for example, that you might be iterating over. Let's say you're going to iterate over a strand of DNA, and that strand of DNA is going to have thousands and thousands of items in it. Well, if you embed loops in loops, that's going to cause performance to be a lot worse than it probably should be. So in math, this is usually called big O notation. So for example, O to the with n to the second power is 2 loops, O to with n to the third power is 3 loops, etc. And if we look on the time versus data input, we can see that the more higher that power gets, the worse the timing related to data processing gets. Like that almost starts to turn into a straight line up. In an example that I saw at work once, I saw somebody not do a very efficient looping mechanism while going through account tests for customer accounts, and he let his program run for about a day and a half, and then it finished. So that was probably around 36 hours that it ran to finish. Then we optimized the looping mechanism in that program, and it finished in 2 hours. So huge difference, potentially huge difference that could result in saving 30 or more hours, sometimes more depending on what you're dealing with. So in short, you don't really have to worry about the math too much, just limit your loops. So try to do as much in one loop as reasonably possible. If you find yourself with multiple embedded loops, you may want to check if you can eliminate some of the loops. Now, in some parts of this, we have to use a little bit of common sense. For example, if you have 10 loops and all those loops will only ever have 3 items in it, that's not going to run very slow at all, because even though you have 10 loops, they all have 3 items, and that's just 30 items total, and that's just not going to take very long to process, even though the loop design might be horribly inefficient. It's really when you start to get to those large data sets that efficiency really starts to hurt. So it's something to keep in mind when you're writing programs with loops in them. Now, let's go ahead and jump in the lab environment and take a quick look at our lessons and our examples and our questions and answers. All right, here we are again. I'm in section 5. I need to go to section 6. Now, I'm just going to keep iterating this. If you may have made changes in the previous lesson and now Git won't let you check out the new section until you commit your changes. We're not going to go over that. We're just going to get rid of any changes by doing a git reset hard. Now, if you're using Git version control for a project, you of course would want to be sure that you really want to lose that data, because it gets erased. There's no way to get it back once you do a git reset hard. And now I need to change to the correct section. So I'm going to say git checkout. Let's see, what is it? It is 38557E. Let's see, deletion of objective files has failed. Try again. Let's see, what is going on? Do I have it open? I might have it open. Let's close all this. Then let's try it again. Yes, there it goes. It worked. So if you run into that, make sure you have the resources there closed. Otherwise, the Windows operating system may not let you, or may not let Git delete those items to replace them with the correct items. So we are in section 6. Let's take a look at the cheat sheet. Again, be sure to look over and review the cheat sheets. Sometimes it helps drive home that concept, or contains some other concepts that might not have been as strongly talked about throughout the lesson. So let's take a quick look at one of the examples. Let's take a look at example 2. Go ahead and right click and run. And we can see that Z never printed out. But let's go ahead and get rid of this statement. Now we're going to see Z. So I'm going to go ahead and run this. And there it is. There's Z. Let's put that statement back. Run it again. And what we can see is that when we hit that value of Z, the continue statement is continuing on to the next iteration in the loop. We set the value of D to Z. That's why we don't see D in here. And when we set that, because the list is a mutable data type, we don't create a new data object. The original data object is changed. Now, why does that matter? Let's take a quick look here. Let's set D equal to C. Okay, so now we have another variable pointing to the same data object. All right. And I'm going to go ahead and change that to a D. So this is just some additional information, really. So now we're looping through D. Now, if they were new data objects, when we made this change, D would be unaffected and would still have a D in it. We'll go ahead and get rid of this. So we're going through list D. Let's go ahead and run. We still see that Z in there, even though we're going through list D and we changed C. Now, how is that different from an integer? Well, let's see. A equals 5, B equals A, right? And then we'll set A equals to 7, right? Now, if they work the same way, the value of B would change to a 7. But let's print B out and see what happens. All right? And this is the key concept between mutable and immutable. All right? So we run that, we get a 5 out, even though we're printing B. And that is because when we changed A, and that is because when we changed the value of A, because it's immutable, it made a new data object. And that didn't occur up here because the list is mutable. And they both still point to the same data object. Whereas when we change the value of A, it got a new data object. So that's the difference there. Okay. So that was a good look at the example and why mutable and immutable matters. Again, we'll reiterate that as we work through our course. Let's go take a look at our exercise. Let's take a look at our questions. Loops. Is this the question? Okay. Task 1. Identify the problem associated with efficiency below. Well, that's one of the last topics we covered in the slideshow. Task 2. What is one major difference between the while and for loop? Okay. It's a decent question. And task 3, create a loop that has a conditional break and continue statement. Well, you know, I think these tasks are pretty straightforward, so make sure to give them a good try before you watch the answers. So pause the video, and because I'm about to go over the answers. Here we go. Let's go over the answers. I hope you got through it. All right, task 1 answer. Multiple embedded loops have a negative impact on performance. Multiple nested loops should be avoided when possible. Yes. Task 2 answer. A while loop loops around until some given condition is false. A for loop is used to iterate over lists. Now that doesn't just have to be lists. It could be tuples or other data objects, but we've only covered lists to this point. Actually, we did go over tuples, but it's fine if you didn't list every data object. The point is we use a for loop for iteration. And task 3 answer. We see that A is equal to a list, and then we're using a break and a continue statement based on an equality check of I, which becomes a list item as we iterate through list A. Okay, so that completes this lab environment. Let's go ahead and jump back into the slideshow. All right, here we are. We finished with this slide already. Let's move on to the conclusion. Section conclusion, we learned about the Python loop structures, the two main ones, the while loop and the for loop. We learned about break and continue, and we also discussed loop efficiency. So this finishes this lesson. I hope you enjoyed it, and I hope to see you in the next. Thank you.